The sun, a blazing ball of fire, a giant in the sky, the heart of our solar system. Its presence dominates everything around it. Its gravity holds the planets in orbit. Its energy fuels life on Earth. Without the sun, our world would be a very different place. Imagine a world without warmth, a world shrouded in darkness, where temperatures plummet to unimaginable lows. This is the reality we would face without the sun. Its energy, radiating across millions of miles of space, bathes our planet in light and heat. It's a constant reminder of the powerful forces at play in the universe. And yet, for most of us, the sun is just a familiar sight in the sky. We often take for granted the incredible role the sun plays in our lives, but it's the driving force behind our weather patterns, the engine of our climate, and the source of energy for life itself. Understanding the sun is about more than just astronomy. It's about appreciating the delicate balance of our planet and the forces that make it habitable. Let's delve into the heart of our solar system and uncover the secrets of the star we call the sun. The sun is not just a distant object in the sky, it's a constant presence in our lives. We feel its warmth on our skin, we see its light illuminating our world, and we rely on its energy for our very existence. But the sun's reach extends far beyond these obvious manifestations. It influences our planet in countless ways, shaping our environment and driving our climate. One of the most fundamental ways the sun affects Earth is through the changing seasons. As our planet orbits the sun, its axis of rotation remains tilted. This tilt causes different parts of Earth to receive varying amounts of sunlight throughout the year. When the northern hemisphere is tilted towards the sun, we experience summer. Conversely, when it's tilted away, we experience winter. This simple tilt is responsible for the dramatic shifts in weather patterns we observe throughout the year. It dictates the growth cycles of plants and animals, influences ocean currents, and even impacts our moods and behaviors. The sun's influence on Earth's seasons is a testament to the interconnectedness of our solar system. The uneven heating of Earth's surface by the sun creates temperature differences that drive atmospheric circulation. The sun's energy also powers the water cycle, driving evaporation from oceans and lakes, forming clouds, and eventually falling back to Earth as precipitation. The sun, a celestial furnace burning millions of miles away, is the primary source of energy for our planet. Its energy reaches Earth in the form of electromagnetic radiation, a spectrum of waves that includes visible light, infrared radiation, heat, and ultraviolet, UV radiation. This radiant energy is the driving force behind Earth's climate system, influencing everything from global temperatures to ocean currents. Upon reaching Earth's atmosphere, a portion of the sun's energy is reflected back into space, while the rest is absorbed by the Earth's surface and atmosphere. This absorption of solar energy is what warms our planet, making it habitable for life as we know it. The balance between incoming solar radiation and outgoing infrared radiation is crucial for maintaining Earth's average temperature. The sun's energy provides the fuel for this system, driving atmospheric and oceanic circulation patterns, influencing weather events and shaping regional climates around the globe. While the sun's energy warms our planet, the Earth's atmosphere plays a crucial role in trapping some of that heat, preventing it from escaping back into space. This natural process, known as the greenhouse effect, is essential for maintaining Earth's habitable temperature. Certain gases in the Earth's atmosphere, such as carbon dioxide, water vapor, methane, and nitrous oxide, act like a blanket, absorbing outgoing infrared radiation and re-emitting it in all directions. This trapping of heat within the atmosphere keeps Earth's average temperature at about 15 degrees Celsius, much warmer than it would be without an atmosphere. However, human activities, particularly the burning of fossil fuels like coal, oil, and natural gas, have significantly increased the concentration of greenhouse gases in the atmosphere, enhancing the greenhouse effect and leading to a gradual warming of the planet. The delicate balance of the greenhouse effect is crucial for maintaining a stable and habitable climate on Earth. Understanding how the sun's energy interacts with the Earth's atmosphere and the role of greenhouse gases is essential for addressing the challenges posed by climate change and ensuring a sustainable future for our planet. The sun's energy not only drives Earth's climate, but also plays a significant role in shaping daily weather patterns. The uneven heating of Earth's surface by the sun creates temperature differences that drive atmospheric circulation, leading to the formation of wind systems, cloud formations, and precipitation patterns. The equator, receiving the most direct sunlight, warms more than the poles. This temperature difference creates a pressure gradient, with warm, less dense air rising at the equator and flowing towards the poles. Conversely, cooler, denser air at the poles sinks and flows back towards the equator. The rotation of the Earth further influences these wind patterns through the Coriolis effect, causing winds to curve as they travel long distances. These large-scale wind patterns, driven by the sun's energy, play a crucial role in transporting heat and moisture around the globe, influencing regional climates and weather events. While the sun may seem like a constant source of energy, its output actually varies slightly over time. These variations in solar activity, often manifested as sunspots, can have subtle but noticeable effects on Earth's climate. Sunspots are temporary dark spots on the sun's surface that appear darker because they are cooler than the surrounding areas. These spots are caused by intense magnetic activity within the sun and are often associated with solar flares and coronal mass ejections, which release bursts of energy and charged particles into space. The number of sunspots visible on the sun's surface waxes and wanes in an 11-year cycle known as the solar cycle. These variations in solar output, while relatively small, can influence Earth's climate. Over very long timescales, the sun's energy output gradually increases as it ages. This gradual brightening of the sun has significant implications for the habitability of Earth over billions of years. As the sun continues to evolve, it will slowly become hotter and brighter. In about 1 billion years, the sun's luminosity will have increased by about 10%, making Earth's surface too hot for liquid water to exist. This will mark the end of Earth's current habitable period. Understanding the sun's evolution and its impact on Earth's climate is crucial for comprehending the history and future of life on our planet. Understanding the sun key to our future on Earth. The sun, our nearest star, plays a vital role in shaping Earth's climate, weather patterns, and the very existence of life as we know it. Its energy warms our planet, drives atmospheric and oceanic circulation patterns, and fuels the process of photosynthesis that sustains nearly all life on Earth. Understanding the sun's influence on our planet is essential for addressing the challenges posed by climate change, predicting future climate scenarios, and ensuring a sustainable future for humanity. By harnessing this knowledge, we can strive to protect our planet, mitigate the effects of climate change, and ensure a brighter future for generations to come. Solar energy, a powerful resource. The sun, a celestial powerhouse, bathes our planet in a constant stream of energy. This solar energy, in the form of light and heat, has sustained life on Earth for billions of years. Today, we are increasingly recognizing the immense potential of solar energy to power our modern world. Every hour, the sun delivers enough energy to Earth to meet the entire world's energy needs for an entire year. This staggering amount of energy is readily available, renewable, and essentially inexhaustible on a human timescale. Unlike fossil fuels, which are finite and contribute to climate change, solar energy offers a clean and sustainable alternative. Harnessing solar energy can significantly reduce our reliance on fossil fuels, mitigating the harmful effects of greenhouse gas emissions and promoting a healthier planet. Harnessing the sun's solar technologies. Over the past few decades, significant advancements in solar technology have made harnessing the sun's energy more efficient and affordable than ever before. Solar panels, also known as photovoltaic cells, convert sunlight directly into electricity through the photovoltaic effect. When sunlight strikes a solar panel, it energizes electrons in the panel's semiconductor material, typically silicon. These energized electrons flow through an electrical circuit, creating an electric current. This process is remarkably clean, producing no emissions or noise pollution. Solar energy technologies are constantly evolving, with researchers and engineers developing new materials, designs, and applications to enhance efficiency, affordability, and versatility. The environmental benefits of solar energy are undeniable. By reducing our reliance on fossil fuels, solar energy significantly reduces greenhouse gas emissions, mitigating climate change and improving air quality. The burning of fossil fuels releases harmful pollutants into the atmosphere, contributing to smog, acid rain, and respiratory problems. Solar energy offers a clean alternative, producing no emissions during operation. This clean energy source helps protect our environment and safeguard public health. Furthermore, solar energy production requires minimal water usage compared to traditional power plants, which often require vast amounts of water for cooling purposes. The environmental benefits of solar energy extend beyond just reducing pollution. The future of solar power is bright, with projections indicating continued growth and technological advancements in the coming years. As the cost of solar technology continues to decline and efficiency improves, solar energy is becoming increasingly competitive with traditional energy sources. Governments and policymakers worldwide are recognizing the importance of transitioning to renewable energy sources, with many implementing policies and incentives to encourage the adoption of solar power. These policies, combined with growing public awareness and demand for clean energy solutions, are driving the expansion of the solar energy market. Advancements in energy storage technologies, such as batteries, are further enhancing the viability of solar power by addressing the intermittency issue associated with solar energy production. The integration of solar energy into smart grids, which use digital technologies to optimize energy distribution and consumption, is another exciting development that promises to enhance the reliability and efficiency of solar power. While solar energy is most commonly associated with electricity generation, its applications extend far beyond just powering our homes and businesses. Solar thermal technologies, for example, can be used for a variety of purposes, including water heating, space heating, and even industrial processes. Solar water heaters use sunlight to heat water for domestic and commercial use, reducing the need for electricity or gas-powered water heaters. These systems can significantly reduce energy consumption and lower utility bills. Solar space heating systems use sunlight to heat air or water, which is then circulated throughout a building to provide warmth. These systems can be particularly effective in cold climates, reducing the need for traditional heating systems. Solar thermal energy can also be used in industrial processes, such as drying crops, producing steam for manufacturing, or even generating electricity in concentrated solar power plants. The versatility of solar thermal technologies makes them a valuable asset in a wide range of applications. The sun's energy has always been a fundamental driver of life on Earth, and now it is inspiring a new wave of innovation and technological advancement. From developing more efficient solar panels to exploring new applications for solar energy, human ingenuity is finding creative ways to harness the power of the sun. Research into new materials, such as perovskites, promises to further enhance the efficiency and affordability of solar cells, making solar energy even more accessible. Perovskite solar cells have shown remarkable potential for achieving higher energy conversion efficiencies than traditional silicon-based solar cells. Nanotechnology is another exciting frontier in solar energy research, with scientists exploring the use of nanomaterials to create more efficient and lightweight solar cells. Nanomaterials offer unique properties that can enhance light absorption, electron transport, and overall device performance. The quest to harness the sun's energy is driving innovation not just in the field of solar technology, but also in related fields such as energy storage, smart grids, and sustainable materials. The pursuit of clean and sustainable energy solutions is fostering collaboration across disciplines and pushing the boundaries of human ingenuity. The sun, a blazing star millions of miles away, is the ultimate source of energy for almost all life on Earth. This energy, in the form of sunlight, is captured by plants, algae, and some bacteria through an extraordinary process called photosynthesis. This process is nothing short of a miracle, transforming light energy into chemical energy that sustains life as we know it. Imagine a world without plants. No towering trees, no vibrant flowers, no lush green fields. This is the world we would inhabit without photosynthesis. This process is the foundation of most ecosystems, providing the food and oxygen that countless organisms, including humans, depend on for survival. Photosynthesis is like a cosmic dance between the sun and life on Earth. Sunlight provides the energy, while plants and other photosynthetic organisms provide the stage and the choreography. The result is a symphony of life, a delicate balance of energy flow and matter transformation that sustains our planet. This process is a testament to the interconnectedness of all living things. From the smallest bacteria to the largest whales, life on Earth is ultimately dependent on the sun's energy, harnessed through the remarkable process of photosynthesis. At the heart of photosynthesis lies chlorophyll. This pigment in chloroplasts captures light energy from the sun. Chlorophyll absorbs blue and red light, exciting electrons. This energy converts carbon dioxide and water into glucose. Like a natural solar panel, it powers plant growth. Chlorophyll's efficiency allows plants to thrive everywhere. Photosynthesis is a complex process with two main stages: light-dependent reactions and the Calvin cycle. Chlorophyll captures light energy to split water molecules, releasing oxygen and generating ATP and NADPH. In the Calvin cycle, ATP and NADPH convert carbon dioxide into glucose. This process sustains life on Earth by converting light energy into chemical energy. Photosynthesis highlights the interconnectedness of the physical and biological worlds. One of the most remarkable aspects of photosynthesis is that the very oxygen we breathe is a byproduct of this life-sustaining process. As water molecules are split during the light-dependent reactions of photosynthesis, oxygen is released into the atmosphere. This oxygen, initially a waste product of early photosynthetic organisms, transformed the Earth's atmosphere over billions of years, paving the way for the evolution of oxygen-breathing organisms, including humans. The oxygen we inhale with every breath is a testament to the power of photosynthesis and its profound impact on the history of life on Earth. The release of oxygen by photosynthetic organisms also plays a crucial role in regulating Earth's climate. Oxygen is a highly reactive element, and its presence in the atmosphere helps to moderate the greenhouse effect by reacting with methane, a potent greenhouse gas, and breaking it down. Furthermore, the ozone layer, which protects life on Earth from harmful ultraviolet radiation from the sun, is formed from oxygen molecules in the upper atmosphere. The ozone layer absorbs most of the sun's UV radiation, preventing it from reaching Earth's surface and harming living organisms. The oxygen we breathe, a seemingly simple gas, is a testament to the interconnectedness of life on Earth and the profound impact that photosynthesis has had on our planet's history and its ability to support life as we know it. Photosynthesis is not just a cellular process, it's a global phenomenon that shapes our planet's atmosphere, climate, and ecosystems. Every year, photosynthetic organisms on land and in the oceans convert an estimated 100 to 115 billion metric tons of carbon dioxide into organic matter, releasing a similar amount of oxygen into the atmosphere. This massive scale of carbon fixation plays a crucial role in regulating Earth's climate by removing carbon dioxide, a greenhouse gas, from the atmosphere. Photosynthesis helps to mitigate the effects of human activities such as the burning of fossil fuels, which release large amounts of carbon dioxide into the atmosphere, contributing to climate change. Furthermore, photosynthesis is the foundation of most food webs on Earth. Plants, algae, and some bacteria that can produce their own food through photosynthesis are known as producers. They form the base of the food chain, providing energy for all other organisms, including herbivores, carnivores, and decomposers. The energy stored in the organic molecules produced during photosynthesis is passed along food chains, supporting a vast diversity of life on Earth. From microscopic plankton in the oceans to towering redwood trees, photosynthesis fuels the growth and sustenance of countless organisms. The global impact of photosynthesis extends beyond just carbon cycling and food webs. Photosynthetic organisms play a vital role in maintaining soil fertility, preventing erosion, regulating water cycles, and providing habitats for a wide array of species. The Sun, a celestial powerhouse, is the ultimate source of energy that sustains almost all life on Earth. Through the remarkable process of photosynthesis, plants, algae, and some bacteria capture sunlight and convert it into chemical energy, fueling the growth and sustenance of countless organisms. From the air we breathe to the food we eat, life on Earth is intricately linked to the sun's energy. Photosynthesis not only provides the oxygen we need to survive, but also forms the foundation of most food webs, supporting a vast diversity of life on our planet. The sun's energy, captured through photosynthesis, drives the Earth's climate system, regulates atmospheric composition, and shapes the ecosystems we depend on. Understanding the intricate relationship between the sun, photosynthesis, and life on Earth is crucial for appreciating the delicate balance of our planet and the importance of protecting our environment. As we continue to explore the cosmos and search for life beyond Earth, the search for signs of photosynthesis serves as a key indicator of the potential for life on other planets. The presence of photosynthetic organisms would suggest the existence of liquid water, a source of energy, and the building blocks of life, making the search for photosynthesis an integral part of our quest to understand our place in the universe. The sun, a radiant beacon, captivates us with its light and warmth. Beyond its brilliance lies a realm of hidden forces, driven by intense magnetic fields. The sun emits a continuous stream of charged particles known as the solar wind. This wind flows outward, carrying the sun's magnetic field. Occasional eruptions like solar flares unleash bursts of energy. These solar storms can disrupt Earth's magnetic field and technology. Understanding these forces is crucial for safeguarding our technology. Our star, while life-giving, can unleash powerful forces. The sun, despite its seemingly serene presence in the sky, is capable of unleashing powerful eruptions that can send shockwaves throughout the solar system. These eruptions, known as solar storms, originate from intense magnetic activity on the sun's surface, particularly in regions marked by sunspots, which are cooler, darker areas associated with strong magnetic fields. Solar flares, one type of solar storm, are sudden, intense bursts of radiation that release vast amounts of energy in the form of light and charged particles. These flares, often compared to explosions on the sun's surface, can last from minutes to hours and release as much energy as 1 billion atomic bombs. While most of this energy is harmlessly radiated into space, some can reach Earth, impacting our upper atmosphere and disrupting radio communications. Coronal mass ejections, another type of solar storm, are even more powerful than solar flares. CMEs are massive eruptions of plasma, a superheated gas of charged particles from the sun's corona, its outermost atmosphere. These eruptions can release billions of tons of plasma into space at speeds of millions of miles per hour. When directed towards Earth, CMEs can interact with our planet's magnetic field, triggering geomagnetic storms. These storms can disrupt power grids, interfere with satellite communications and navigation systems, and even pose risks to astronauts in space. Understanding and predicting these solar storms is crucial for mitigating their potential impacts on our technology-dependent society. While solar storms can pose challenges to our technological infrastructure, they also offer a breathtaking display of nature's beauty in the form of auroras. These celestial light shows, known as the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere, paint the night sky with vibrant hues of green, blue, red, and purple. Auroras occur when charged particles from the sun, carried by the solar wind or released during solar storms, collide with atoms and molecules in Earth's upper atmosphere. These collisions excite the atmospheric gases, causing them to emit light at specific wavelengths, creating the mesmerizing auroral displays. The colors of the aurora depend on the type of gas being excited and the altitude at which the collisions occur. Green, the most common auroral color, is produced by excited oxygen molecules at lower altitudes. Red auroras, less common but equally stunning, are produced by excited oxygen at higher altitudes or by excited nitrogen molecules. Auroral displays are most often observed at high latitudes near Earth's magnetic poles, where the planet's magnetic field lines converge, funneling the charged particles towards the poles. However, during particularly intense geomagnetic storms, auroras can be seen at lower latitudes, offering a rare glimpse of this celestial spectacle to a wider audience. As our reliance on technology grows, so too does our vulnerability to the vagaries of space weather. The term space weather refers to the constantly changing environmental conditions in space, driven primarily by the sun's activity. Just as terrestrial weather can impact our daily lives, space weather can disrupt our technological infrastructure, sometimes with significant consequences. Solar flares, with their intense bursts of radiation, can interfere with radio communications, particularly high-frequency radio waves used for aviation and maritime communication, as well as for shortwave radio broadcasting. These disruptions can be significant, potentially affecting emergency communications and navigation systems. Coronal mass ejections, with their massive bursts of charged particles, pose even greater risks to our technology. When CMEs interact with Earth's magnetic field, they can induce geomagnetic storms, which can disrupt power grids, causing widespread blackouts. In 1989, a severe geomagnetic storm caused by a CME led to a blackout in Quebec, Canada, affecting millions of people. Space weather can also impact satellites orbiting Earth. The increased radiation from solar flares and CMEs can damage satellite electronics, shorten their lifespan, and disrupt the vital services they provide, such as communication, navigation, and Earth observation. Understanding and mitigating these risks is crucial for ensuring the reliability of our space-based infrastructure. The sun's influence extends far beyond Earth, shaping the environment of the entire solar system through a constant stream of charged particles known as the solar wind. This invisible wind, flowing outward from the sun at supersonic speeds, carries with it the sun's magnetic field, creating a vast magnetic bubble known as the heliosphere, which encompasses the entire solar system. The solar wind interacts with the planets and other objects in the solar system, shaping their atmospheres and magnetic fields. For planets with weak or no magnetic fields like Mars, the solar wind can strip away their atmospheres over time, contributing to their dry and barren conditions. The solar wind also plays a crucial role in creating the beautiful tails of comets. As comets approach the sun, the heat vaporizes ice and dust from their surfaces, creating a glowing coma or atmosphere around the comet's nucleus. The solar wind then pushes this material away from the comet, forming the characteristic tails that can stretch for millions of kilometers. The study of the solar wind and its interactions with the planets and other objects in the solar system provides valuable insights into the evolution of the solar system and the processes that shape planetary environments. It's a reminder that the sun is not just a source of light and heat, but also a dynamic and influential force shaping the celestial landscape. The sun, our life-giving star, has a finite lifespan. Over billions of years, the sun will change, eventually becoming a red giant. Its outer layers will expand, engulfing Mercury and Venus. Eventually, it will shed its outer layers, forming a planetary nebula. The remaining core will become a white dwarf, slowly cooling over billions of years. As we conclude our exploration of the sun's influence on Earth, we are left with a sense of awe for this celestial giant. The sun is the lifeblood of our planet, the conductor of our climate, and the ultimate source of energy. From photosynthesis to weather patterns, the sun's impact is woven into our existence. It shapes our world in ways we're only beginning to comprehend. The sun continues to inspire wonder and humility. Perhaps the most profound lesson the sun offers is the delicate balance that governs our existence on Earth. The sun's energy, while essential for life, must be carefully regulated to maintain a habitable climate. Too much solar radiation would scorch our planet, while too little would plunge us into a frozen wasteland. Earth's atmosphere, with its protective ozone layer and its greenhouse gases, plays a crucial role in this balancing act, filtering the sun's radiation and trapping just the right amount of heat to maintain a temperature range suitable for life. This delicate equilibrium, however, is threatened by human activities, particularly the emission of greenhouse gases from the burning of fossil fuels. As we increase the concentration of greenhouse gases in the atmosphere, we are effectively throwing a blanket over our planet, trapping more heat and disrupting the natural balance. The consequences of this disruption are already being felt around the world, from rising sea levels and more frequent extreme weather events to shifts in plant and animal life cycles. The sun story is therefore not just one of scientific curiosity, but also one of profound relevance to our future on Earth. Understanding the sun's influence on our climate is essential for making informed decisions about how we manage our energy resources and mitigate the impacts of climate change. Our future on this planet is inextricably linked to our relationship with the star that sustains us. Throughout human history, the sun has been a source of inspiration, wonder, and even fear. Ancient civilizations, recognizing the sun's life-giving power, often worshipped it as a deity, incorporating it into their myths and rituals. The sun's daily journey across the sky, its disappearance at night and reappearance at dawn, became metaphors for life, death, and rebirth in many cultures. For artists, the sun has been a muse, inspiring countless paintings, sculptures, poems, and musical compositions. From Vincent van Gogh's vibrant sunflowers capturing the sun's radiant energy to Claude Debussy's evocative La Mer, evoking the interplay of sunlight and ocean waves, the sun's beauty and power have captivated human imagination for millennia. The sun's influence extends beyond the arts, inspiring scientific inquiry and technological innovation. The development of solar energy technologies, for example, is a testament to human ingenuity, harnessing the sun's power to provide clean and sustainable energy for a growing global population. The quest to understand the sun's fusion reactions has also fueled research into nuclear fusion as a potential source of clean energy here on Earth. The sun's story is therefore not just one of scientific facts and figures, but also one of human curiosity, creativity, and our enduring fascination with the cosmos. It is a reminder that science and art are not mutually exclusive, but rather complementary ways of exploring and understanding the universe around us. As we marvel at the sun's power and its intricate relationship with our planet, we must also acknowledge our responsibility as stewards of our home. The Earth is a precious and fragile oasis in the vastness of space, and our actions have consequences that ripple throughout the delicate web of life. The challenges posed by climate change, driven in part by our reliance on fossil fuels, underscore the urgent need to transition to cleaner and more sustainable energy sources. The sun, with its inexhaustible supply of energy, offers a beacon of hope in this regard. Investing in solar energy, energy efficiency, and other renewable energy technologies is not just an environmental imperative, but also an economic and social one. It is an investment in our collective future, ensuring access to clean energy, creating jobs, and reducing our reliance on polluting and finite resources. Beyond energy, we must also address the broader environmental challenges that threaten the delicate balance of our planet, from deforestation and biodiversity loss to pollution and unsustainable consumption patterns. The sun's story reminds us that we are all interconnected, part of a larger web of life that depends on a healthy and vibrant planet. As we look to the future, the sun will continue to play a pivotal role in our destiny. While the sun's ultimate fate, billions of years from now, will have profound implications for Earth, our more immediate concern is ensuring a sustainable future for humanity on this planet. The sun's energy will continue to fuel life on Earth for billions of years to come, providing us with ample opportunity to address the challenges we face and create a brighter future for generations to come. Harnessing the sun's power through solar energy and other renewable energy technologies will be crucial for meeting our growing energy needs while reducing our impact on the planet. Beyond energy, the sun's story can inspire us to think more broadly about our place in the cosmos and our responsibility to protect the pale blue dot we call home. It can foster collaboration and innovation, driving us to explore new frontiers in science, technology, and sustainable living. The challenges ahead are significant, but the sun's enduring presence serves as a constant reminder of our potential for resilience, adaptability, and ingenuity. Just as life on Earth has evolved over billions of years to thrive under the sun's radiance, so too can humanity rise to the challenges of the 21st century and create a more sustainable and equitable future for all. Our sun, while unique to us, is one star among billions in the Milky Way galaxy. Our galaxy is just one of billions in the observable universe. This humbling realization puts our existence into perspective. As we explore the cosmos, the sun serves as a benchmark. The study of exoplanets reveals a breathtaking diversity of worlds. Some may harbor conditions suitable for life. The sun's story is about the fundamental nature of stars. It inspires new generations of explorers and dreamers. As we gaze at the night sky filled with distant stars, let us remember our profound connection with the sun. It binds us to the cosmos and the future ahead. May we always strive to understand and appreciate the sun's influence.